We're not doing grade sheets this year, at least that's the current plan, because Google Classroom is going to replace that puzzle piece for the most part. We are keeping up with notebooks. It's going to be the same as last year, which I'll explain in just a second what that means. So we are doing notebooks, and you are getting a notebook grade that is separate from your homework grade and your notes grade. You're going to get different grades for those things. So for your sake, the notebook has, you put tabs in it, and each tab is a chapter. So each is not like one thing for notes, one thing for whatever else. So in the tab, you'll have the first thing that's in there will be all your notes from that chapter. Then the next thing that needs to be in the tab is your homework from that chapter. And then quizzes. And then the test, which I'll probably stick in there because I'll be giving you back your test with your notebook, because we are going to turn in our notebooks with our tests like we did last time as well.
I couldn't get tabs.
That's fine. You don't need them today. So when you get them, add them, and we'll all move on with life. Be great. Yeah. So that's the way the notebook gets laid out. One tab, one chapter, these things go in there. So in Google Classroom, you probably already noticed, but if you didn't already notice, the notes and homework, the due date was set the day before class. The point of, and that was not an accident, that was intentional, because I don't want you doing it at 7 o'clock in the morning on the day of class. That's not a good idea for you, and so I decided to make it due the day before to help you. How kind am I? So you do need to submit a picture of your notes and a picture of your homework. I am grading those. It's still a completion grade. I'm not grading the answers of those. We'll deal with that in class. So as far as, you know, I haven't got any questions from y'all about this, and so probably y'all are all fine, but because y'all are older and whatever else. But the picture needs to be good enough that I can kind of sort of see what's good. Like, I don't have to see it perfect. What I am looking for on the notes, I'm looking for, are they complete? Did you take all the notes? If I wrote it down, did you write it down? Do they have like titles of stuff? Is it organized well enough? It doesn't have to be like immaculate or great or whatever else. I'm not expecting that. I'm expecting it to be, basically I'm expecting them to be usable notes. If the notes are good enough that you can go back and get some benefit from them in the future, then that's fine. Did you take all the notes from the videos, all the things? For the homework, I'm expecting you to attempt every single problem, to put something on every single problem that you did. Now, you almost certainly will have questions on some problems. I want you to give it a shot. If at the very least, at the absolute least, write the equation, give something, put a question mark for the rest, and then we'll do it in class and whatever else, all the things. Okay? But you need to, I'm looking for, and I'm not grading the numbers, I'm not comparing it to a key or anything else like that. We'll deal with that in class, all that kind of stuff. I am looking for, does the problem have work that at least kind of sort of looked like it probably was attempted to do something relating to that problem? Does that make sense? So not scribbles, not whatever else, proper high school looking work that at least was attempted to fit that problem. It may be off in left field. You may have messed it up 6 ways from Sunday. That's possible. That's one of the reasons why the homework fits in the pattern where it fits, because that's really the point of the homework, is to kind of try the stuff out and see where we are, see where we have questions, see where we're stuck, see what needs to get ironed out and fixed. And then in class, we'll take questions and work through problems and do all of those kind of things and figure stuff out from there. And yeah, so then you take a picture of that and do the things and whatever else. For your homework and tests and whatever, at least give your answers a box or a circle, just to do it, whatever else. Don't highlight your answers. Highlighters and pencil don't work. That's just not a fun plan. So, and so you submit that, and then so it should be super easy to get 100 on your notebook grade, because you will have already done the Google Classroom thing and already have the stuff in there and whatever else. So your notebook grade that you get should be, excuse me, should be an easy 100, right? All right, any questions about the class itself? How it's gonna work? Make sense? Changes make sense? The new things make sense? Okay, all right. So let's look at your assignments for the day. Sets. What numbers did I assign on this one?
2 to 30.
2 through 30. Did y'all notice the pre-cal book does it different? It doesn't have the little check your understanding section. It's just a big old block of questions. Big old block of practice problems.
All I noticed was that the answers in the back are all the odds, and I was like, oh, that's why you need to do evens. Because my dad was like, okay, can you just look at the answers in the back and see if that helps at all? I'm like, they're all odds, Dad. That's all.
Yeah. So, number 2. K is the set. B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z. And it's true. It says, use set notation to write the elements of each set. Then determine whether the statement about the set is true or false. Number 4 is the set. V is the set containing Alabama, Florida, North Carolina, South Carolina, Tennessee, and it is false. Number 6, I weren't thinking you were going to have to do more true-false stuff since geometry, were you? Oh no. Guess what? We're even going to do some things that are called proofs. They're a lot different than they were in geometry. Trig proofs are like thebomb.com. I love trig proofs. They're so great.
How are you supposed to write down set notation?
So set notation, so like for example, number 10, you would write it like this. So A equals the set 1, 2, 6, 9, 10, is 11, 12, is that right? Something like that. No, not 11. There's no 11 in it. Yeah, so that would be the first part of the answer on number 10, and 8 is not an element of A. Would be the full answer for number 10. So back to number, 6? 6, the set including Saturday and Sunday, and it's true. 8 is the set would be S equals. So you could list them all. They use the shortcut way of writing it, which would be a great choice. And there's oftentimes a shorter way to write a set if it includes a list, a known list, or something like that. So what they did on 8 is S equals all states except Alaska and Hawaii, and it is true. Number 10, I already said. Number 12 is false. Not all of the elements of U are also elements of A. Number 14 is true. 2 is an element of E. 16 is true. 6 is not an element of F. 18 is the null set, and I don't remember, I think I talked about this in the video, but the null, you would just write P in curly braces. (20) is also the null set. 22 is...
Wait, how's 18 null?
let me get through the things and then I'll come back and I'll answer that question. Number 22 is set 2, 3, 6, 9. 24 is the set 2, 9, 10. We go through 30, is that what we did? Okay. Number 26 is the set 1, 6. Number 28 is set 1, 2, 3, 6, 7, 9, 10, 11, and 12. And number 30 is invisible. Where'd 30 go? Well, I know, but 30 doesn't have an answer. It's invisible. We may just have to do 30 because I can't find the answer. So 30 is some set containing something, but we'll just do it to say for sure. So now, what questions? You had 18. How is that the null set? Let's take a look at 18. So for 18, we've got a big old Venn diagram. No, just kidding. 18 is not a Venn diagram.
18 is just find each of the following.
Of u. Where is, oh, there's u. There it is. 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 The inverse of u. So u contains all the things. The inverse would contain nothing. If u contains all those things, then the inverse of u wouldn't have anything in it. That's why it's the null set.
How do you find the complement again?
Complement is the opposite of it. So like the, find one.
Complement means opposite? Is that what you said? What's the definition of complement?
Wait. Let me actually read this problem better.
Complement is everything that's not unique.
Okay, so U is the superset.
Yes.
And then all of these are subsets of it. Okay. So like let's compare 17 and 18 because 17 is the complement of C, whereas U is 18 is the complement of U, right? So the superset, the big one is U. So U is the set in this particular problem containing everything, right? And so if we take the complement of the big set, then there's nothing else left. So that's why it's the null set. So let's compare that though to like 17, which wasn't assigned, but so 17 is, we've got U, which is the superset, the big set that's got everything, and we're trying to find the complement of C. Well, C contains, where is it? C contains 0, 1, 6, 9, and 11. So the complement of C would be everything that isn't in C at that point. So it would be like 2 is not listed in C, and 4 is not listed in C, and 5 is not listed, etc. Does that make sense? So if you complement the biggest set, then there's nothing else left.
Okay, and then I missed like half the problem.
That's-
You said the answer was for them since I was trying to write down the set since I didn't know we were supposed to do that. So
Sure. So are you talking about the true-false part?
yeah.
Okay, sure. Let me hit just the true-false part. Okay, so number 2 was true. Number 4 was false. Oh, by the way, I didn't say that earlier either. Like, so this very first assignment, notes and homework, there's no penalty for late, and just turn in whatever you got. Don't worry about anything beyond that. Just turn in whatever. Like if you left some blank and what, I don't care. Like the first one, you turn it in, you get 100. I don't really care. So don't stress about this first assignment. After this, make sure you turn it on time and meet the criteria and whatever else. So let's see. 4 was false. 6 was true, and 8 was true. Okay, so what other questions?
Circled 28. I don't know why.
Okay. Yeah, and
I also did 20.
you also circled 28.
Yeah.
Okay, so 28, we need to be able to look at the picture. Where's your book? Well, how are you going to look at the picture?
So
Okay.
just learn what the complement was. I thought it was something completely different.
Okay, so now that you understand what the complement is, what the superset in this is going to contain all of these other numbers, right? So the complement of A would be everything that isn't in A. So everything but,
So like 12, 1, 2.
everything but 1, 3, and 6, right? Because 1, 3, and 6 are the only things that are in A.
So I write that down by saying,
I did. I got one.
Let me see.
so I write that down by saying A and like the little thing,
Yeah.
curly brace, and then 12, 11, 14, 15, 2, 7, 9, 10, all the things that are not 3, 1, 6.
Number 28 has, the key is wrong. So yes, that is exactly what you do. Oh, no, the key is not wrong. I read 30. I get it. I found 28. Yeah, so 28 should include 2, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15. 30 should include 1, 2, 3, 6, 7, 9, 10, 11, and 12. I just got confused by the key. Yes. Yeah. 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 Yeah, so 30, oh yeah, 30 is the crazy one, right? 30 is we've got the union of A and B unioned with C, right? Everything in A, B, and C. Yeah, basically. Because the union of A and B would be everything in A and B. And then the union of that with union with C would be also including all of what's in C. So it would be like all the things there is like 1, 2, 3, 6, 7, 9, 10, 11, 12.
So the answer to this one would be just 14 and 15. That's the only one.
No. It's the union, not the intersection.
Oh, so I'm writing everything that is in it.
You're writing everything that is in A, B, and C. This is not in this lesson, but you'll notice with this example, this putting back to kind of some of your geometry days or even early Algebra 1, we start talking about it a little bit, the associative property of prize here, as long as the things matter. Like if we move the parentheses over here, it's still the same set, right? If we union B and C and then union A, we still get the same set, right? That's just extra.
Can we do a simple one?
We can do whatever, yeah. 6, D is the set of days that start with S. And then we want to see whether Sunday is a member of D. So what days start with S?
Saturday and Sunday.
Saturday and Sunday. So the set would be the set with Saturday and Sunday in it. And then is Sunday an element of D, of that set?
Yes.
Yes, so true.
Okay. I don't know how I got that mixed up in my brain.
I don't either.
So, true.
Any other questions on that lesson?
Is that 12 wrong for some reason?
12. U is a subset of what? A, right? Is that what we're saying?
I was thinking of it backwards.
Ah, there you go.
Cool.
Yeah. Yeah. A is a subset of U, but U is not a subset of A. Yeah. Any other questions on that lesson? Okay. Second lesson. Operations with complex numbers. Yay. We'll do 2 through 32. Is that what we probably did?
Yes.
Yeah. All right. 2 through 32. Number 2 is 0. Number 4 is 1. Number 6 is 2. Number 8 is -1. Number 10 is 9 minus 7i. Number 12 is negative 7 plus 4i. Number 14 is negative 4 plus 4i. 16 is 10 plus 6i. 18 is 3 plus 4i. 20 is 20 is 21 plus 20i. 22 is 5 plus 10i. 24 is negative 8 plus 36i. Number 26 is 31 37ths plus 1 37th I. You can, but then it wouldn't be in proper complex number format. 28 is 12 13ths minus 5 13ths I. 30 is negative 4 13ths plus 7 13ths I. 32 is 2 fifths minus 2 times the square root of 3 over 15 plus negative square root of 2 over 5 minus 2 times 6 over 15, all that times I. Isn't 32 exciting? I bet we do that one. What do y'all want to bet?
Yeah, 32 is
Can we start with simpler ones first? 'Cause
I'd love that.
I'm confused how I got 12 wrong.
Okay, let's look at 12. Let's look at 12. So, since we're recording, I should remember to do this. So this is page P something, P8, number 12. What? Negative 3 minus I minus 4 minus 5I.
It was scary, even though it's not that scary, it was scary.
Okay, so what do we need to deal with first?
The negative.
We got to distribute that negative because that's going to apply to everything. Okay. The first one doesn't change. Just bring it down. Negative 3 minus I. What's negative times 4 is negative 4, and then negative times negative 5i is plus 5i. Was that the mistake?
Yeah.
Yep, I thought that was probably going to be the case. What do we do now? Combine like terms. There and there and there and there. So negative 3 plus negative 4 is negative 7, and negative I plus 5i is 4i.
Thank you.
What else do we need to see?
2.
Number 2.
Yes.
6.
I got the first 3 wrong for 6. 2 or 6.
2 or 6. All right, let's do it. So number 2. Same page. Number 2 is I squared plus I to the 8th. They do not. That is false. One of them does, not the other one. Okay, so what is I squared? Negative 1. And then I to the 8th. What do we-
It is 1.
It is 1.
Wait, no, that's what I said. No, it's not.
It is 1 because 4 goes into 8 twice with no remainder. So it is 1.
It's going to be 0.
Yeah.
Okay. And then 6.
Oh yeah, 6 is a little bit interesting. 6 because they throw a curveball at you. You gotta remember something on 6.
You can't have a negative.
You can. It just does something. I don't think that's the word you mean, but possibly. Possibly what you mean is correct, but I don't think. But that's no, not the conjugate. Although fractions are involved, so Conjugate kind of makes sense. Negative 12. Okay, so let's deal with I to the fourth. What does I to the fourth equal? 1. Great. That one's easy peasy. What does negative exponent do?
Change levels.
It does change levels. So he switches and goes down to the bottom. So this turns into 1 over I to the 12th.
Oh.
Now I to the 12th, what does I to the 12th equal?
3, so it's going to be
No, that's lies.
not lies.
4 goes into 12 3 times with no remainder. So it's 1.
No,
It's I to the fourth, yeah.
Thank you for getting us a remainder.
1 over 1. 1.
Yeah, so 1 plus 1, which equals 2. Tricksy hobbits. All right, what else?
32.
Before we get that, can you, what's the answer for 26 again?
Answer to 26 was, where'd it go? Right here. 31 37ths plus 1 37th I.
Okay, got that.
Ooh. Wait, just kidding. Not 32 yet.
Okay,
'Cause if-
what's
yeah.
the proper answer to 28?
28 is 12 13ths minus 5 13ths I.
Okay, I did get that right now. Still have one more of those questions.
Okay. 32.
And what's the answer to 30?
30 was negative 4 13ths plus 7 13ths I.
Okay. Okay, now 32.
Shall do 20 after this. I didn't understand 18 and 20.
Oh, that's when, since it's squared,
It's easy money.
you
2. Here's your conjugate. This problem is the conjugate right here. This is the one. Well, actually, all of these are all of 28 through 26 through 32 are. 2 minus. This one is just especially ugly because of
It's just cruel.
what you have to do for the correct notation. This one ends up to be an exciting jumbled mess. Okay, so what do we got to do?
I don't know.
Turn the conjugate I to the square root of -1.
No, you wouldn't try to put that back. We're going to leave that. We're not going to deal with that right for now.
Do times.
You could, I mean, you could do that, but that's kind of going backwards. But you could. It wouldn't be illegal, and it's important. So this is worth noting, especially in pre-cal, that when you're doing a problem, sometimes you're not going to necessarily find the fastest way to do it first. You're a pre-cal student, and so as long as you do something that is legal and you have a thought that, okay, maybe this is what I do, just do it and see where it goes. Which is really going to be true when we get to trig proofs. Just, okay, well, I see that this exists, try it. You may end up going into someplace real ugly, or you may end up doing it right. If you go ugly, then go back and try again. Okay, so conjugate. What is the conjugate here?
3 plus.
3 minus
The sign changes.
square
Oh.
root of 6i.
Well, that might be why I got it wrong. What's up with sign changes in
The middle, you change the middle sign, the middle sign. Okay. So in the denominator, remember we're just doing full, not FOIL, right? Because the outside and inside are always going to cancel when we multiply the conjugate, right? Always, right? So we just do the first times the last, right? So that's the easy bit. So the first is 3 times 3, which is 9. And then the second one, I'll write this over, Jared, so we don't get too much head scratching here. We've got this times itself, negative. So it's going to be negative this squared, the square root of 6i squared. Square and square root cancel, right?
So we get negative I.
You do. Well, negative 1 actually, because it's going to be I squared. So negative and then 6 and then I squared, which is 1. Excuse me, negative 1. And then negative 1 times 6 is positive 6. So plus 6 is what you're ending up with here.
Oh, gracious.
I missed
Okay, so you distribute the squared before you get rid of the.
Yes, because you're multiplying this times this, negative this times this. So,
Okay, so when you multiply it times the square root, it gets rid of it. So you're still distributing it.
yeah. Okay. And then the top, we got to do everything, right? Because stuff might cancel, but it doesn't necessarily cancel. So 2 times 3 is 6. And then 2 times negative square root of 6i is negative 2 square root of 6i, right? And then negative square root of 2i times 3 is negative 3 square root of 2i. And then we get all kinds of nonsense, right? We got negative times a negative, so it's going to be positive. Deal with that first, right? And then square root of 2 times the square root of 6.
the square root of 12.
Yes, it is. Which can actually be simplified, but we'll deal with that in a minute. And then I times I is I squared, right?
Times 1.
What is times 1?
This
squared.
is I squared. 1.
I squared is negative 1, yep.
So minus 1. Can we put that instead of s squared?
Not minus 1, but times negative 1, which might have been what you meant, but. Okay, so let's start kind of dealing with some pieces, right? So we need our real numbers over here and our complex numbers over there, right? So I'm going to leave the 6 where he's at for now, right? These two, I'm going to move over in a minute, but we'll deal with this, right? Because I squared is negative 1, right? So that turns into negative square root of 12. So minus the square root of 12, right? And then let's put the I ones over here. So minus 2 times the square root of 6, minus 3 times the square, oh, I left off an I, sorry. 3 times the square root of 2i all over 15, right? How we doing so far? Because it's a real part. We want the real parts in the front and the imaginary parts in the second.
Anything that doesn't have an I is real.
Right.
Wait.
It's ugly. He's irrational, but he's real, right?
Plus, that's 12i squared. So wouldn't the
What does I squared equal?
negative 1?
So negative 1 times this is negative this.
Wouldn't the squared cancel out?
No, okay, that's a good question too. This only thing that's squared is the I. There's no parentheses. This is not squared, only this.
Ah,
Yeah, that's a good question.
makes sense. Okay, cool.
Okay, so now we start looking for, is there anything we can simplify? Is there anything we can combine before we start splitting stuff? So is there anything we can simplify? The answer is yes. What can we simplify?
Square root of 12.
Square root of 12. We can't do that. Can't simplify that. We can simplify the square root of 12, right? Remember simplifying radicals, right? So square root of 12, are there any perfect squares that go into 12? 4. So we turn this into the square root of 4 times the square root of 3, which will turn into 2 times the square root of 3, right? So we can turn all of this into 6 minus 2 times the square root of 3 minus 2 times the square root of 6i minus 3 times the square root of 2i all over 15. So it's as simple as it gets. It's just not in correct complex number notation. We need to split off the real part and the imaginary part. So we need to split this off and that off.
Can you not subtract the 2 from the 6?
No, you can't. Why not?
They're not technically the same thing. Since
Correct.
It's 2 square root 3 as like a whole concept.
Yes.
It's a different Tetris piece. I don't know.
They're not like terms. This one's got a square root of 3 and this one doesn't, so they can't go together.
So the 2's connected to the 3.
Yeah. Well, the square root of 3, but yes.
It's like a variable, for
So we
instance.
done?
Like
Yes.
7 x.
Yeah, it is. It's like a variable. No, we're not done. I already said that. We got to split the real part. So we're going to pull the real part apart. So we've got 6 minus 2 times the square root of 3 over 15. And then this is going to get a little bit tricksy because of what's happening here. I'm going to write it and then we'll talk through what's going on. Minus 2 times the square root of 6i plus 3 times the square root of 2i over 15. Okay, so something weird happened. What was the weird thing that happened there?
They changed signs.
They changed signs because now these ones didn't and these ones did. Okay, so let's see if we can figure out what's different. So in these, the 6 is positive and the 2 times the square root of 3 is negative. So these have different signs, right? They don't have a common sign, right? These are both negative. So what I did was I factored that negative out and put it up front. And when you factor out a negative, it changes the signs, right? So they're both, this one's actually positive, right? Because if I was to distribute this negative back in here, this will become negative and this will become negative, right? And so that's why they got flipped. So I think, if I'm not greatly mistaken, yeah, the book actually takes this one step further in the simplification. Now, I would accept either this line or the next one we would write, because I think they're both clean answers at a pre-cal level. This ticks all the boxes because these don't both reduce. Only one of them does. Same thing here. One of these reduces with this, but not both. And so if you circled this and did it, I would give you full credit for this problem. But I'm going to show you what they did in the book so you can see what's going on. So you might notice that 6 and 15 can reduce. Right? 6 and 15 can reduce by 3. And so we can turn this into 2/5. So this is 2/5. This doesn't reduce, so we've got minus 2 times the square root of 3 over 15 here. And then they also put these in parentheses to have the real part and the imaginary part kind of separate that way, right? And so then minus. And the same thing here. This doesn't reduce. So 2 times the square root of 9i over 15. And then plus, this also reduces by 3, right? So 3 divided by 3 is 1. So this is square root of 2i over 5. And so that's where they got that answer in the book. But I would accept either one because you could argue about which one was simpler. I wrote a 9 randomly is where it came from.
I somehow did most of the math right.
Nice. Yeah. So that one, it's kind of a wild problem. We get stuff like this. This picture on the board right here is a perfect example of the difference between pre-cal and algebra 2. They're almost the same class. They're very similar. We're going to cover like a lot of the same topics. We just get wilder stuff in pre-cal. And we also have some trigonometry and some other stuff. And we graph even more things and whatever else. And talk about limits briefly and all the things. But yeah. Pre-cal is, in my humble opinion, the hardest high school math class, period, bar none. It's because of how big of a chunk it is. Because pre-cal is algebra 3, trigonometry, plus what I would call pre-cal, so like learning limits and stuff like that, all shoved into one class. And so pre-cal is a big old beefy class. It is a harder class than college algebra. So if you survive this, then you're probably going to walk into a college algebra class and be like, this is cake. So, it's good. That's the... What? Yeah, sure. It's easy peasy, but we got cobwebs, so we'll dust the cobwebs. Where up there it is. Okay, so 18 is a good example of a super common mistake, like super common, everywhere from Algebra 1 all the way up to pre-cal, obviously. 18, we've got -2 minus I squared. Okay, so I'm going to pay very close attention to these words that I'm going to say before and after I do it. I'm going to show you what the mistake is, not so you'll get stuck and do the mistake, but so that you will not do the mistake. So just to be clear, what I'm writing on the board, do not write down because it's wrong. Okay? So what people will want to do is they'll just square -2 and square -I and then move on with their life and maybe simplify from there. But that is not what this is, because you're missing an entire term if you do that. This 2 doesn't distribute. If this was multiplication, it would. Then the squared would distribute, and that's what would happen, right? But that is not what this is. This is a minus? Yes. So this is -2 minus I times -2 minus I. Okay? So there's a shortcut and a long cut. And you're in pre-cal, so I'm going to remind you of both. So we can do all of FOIL. Do the first -2 times -2 is 4. The outside, -2 times -I is plus 2I. And then -I times -2 is plus 2I. And then -I times -I is plus I squared. You could combine like terms and turn that into -1. So 4 plus 4I minus 1, and then you'd get 3 plus 4I. Right? So you could expand it out and do all of that. You could also remember that there's a shorter way to do it. Right? So you get the first term is just a squared. So -2 squared is 4. To get the middle term, it is 2 times a times b. So 2 times -2 times -I is positive 4I. And then the last one is b squared, so plus -I squared, so plus -1. And then go get the answer. So I don't care whether you use the shortcut method of squaring a binomial or you take the long way. I don't really care. Just find a way to the future.
How did the middle one work again?
It's the formula is a squared plus 2 times a times b plus b squared.
Okay, so then you would just,
Yeah. Yeah. And I don't care what you use. Just don't make the mistake. If you do, don't worry, I'll correct you and hopefully you won't make it again. What other questions do we have? I think that was it. All right. Cool beans. I think we should take a quiz. That sounds reasonable.
Is it open book?
No, but you will need your book. Okay, so your quiz is page P8. And we're going to do numbers 5. And 9, 77.